At the edge of our solar system, there's a cold and mysterious region known as the Oort cloud. It's a hypothetical vast area of icy space objects surrounding the Sun. It's believed to lie far, far away from our star, from 2,000 to 5,000 astronomical units. For comparison, Pluto's orbit carries the planet between 30 and 50 astronomical units from the Sun. And there, in this freezing emptiness, a rogue planet may be hiding right at the moment. At least, that's what new research has recently suggested. Rogue planets are called this way because they don't orbit around any star. They wander the galaxy alone, totally untethered. Without stars, they don't have days or nights, only eternal darkness. Rogue planets are usually kicked out of their planetary systems, doomed to a solitary existence of circling the center of the galaxy on their own. Of the thousands of planets scientists have detected outside of our solar system, only a dozen or so are starless and cruising on their own. At the same time, there might be billions or even trillions of rogue planets wandering around our galaxy. If these estimations are true, it might mean that the Milky Way contains more free-floating planets than stars. Anyway, in 1907, one astronomer started a search for Planet X. It's a hypothetical giant planet moving around the Sun beyond the orbit of Neptune. The scientist was convinced that this planet existed because he had observed some irregularities in the orbits of Uranus and Neptune. His idea led to the discovery of Pluto in 1930. But the dwarf planet was too small to have any serious gravitational impact on the orbit of Neptune, let alone Uranus. These days, the Planet X theory is largely considered to be discredited, but it hasn't stopped astronomers from searching for planets in the far reaches of our solar system. And shockingly, a new study claims there might be one or even more out there, but much, much further away than predicted. An international team of scientists has recently simulated the unstable celestial mechanisms of the early solar system. They've discovered that there's a possibility that a few planet-sized bodies might have come to rest in the Oort cloud. You see, about 4.5 billion years ago, when the solar system was just forming, it was a hectic and unsettled place. Gravity sent debris from the cooling protoplanetary dust cloud hurtling around like cosmic tennis balls. From time to time, large chunks of this debris, even planet-sized ones, were sent flying far enough to escape the Sun's gravity altogether. Such pieces of debris turned into rogue planets. Researchers have seen such space wanderers in distant exoplanetary systems, but according to them, there's a 0.5% chance that one or more of those wayward planets formed in the solar system and ended up in the Oort cloud after drifting away from the Sun. At the same time, it's slightly more likely that a rogue, Neptune-like planet was snagged by the Sun's gravity from another planetary system. And then, this planet came to rest somewhere in the Oort cloud. The chances that this scenario is true reach 7%. If this turns out to be the case, then a space body similar to Planet X might indeed be hiding out there, on the outskirts of our solar system. The only problem is that it would still be too far away to have any impact on Neptune's orbit. In any case, most researchers are convinced that the Oort cloud is made up of a collection of way smaller icy objects. But given the distance to the Oort cloud and its enormous size, we may never really figure out what is lurking out there.
While we may think of ourselves as advanced after catching a glimpse of the 8 planets of our solar system and their 200 moons, we really have little idea of what's out there. So much so that there's speculation that there might be one more planet in our solar system. Scientists call it Planet X or Planet 9. This undiscovered world could be hidden way out past Neptune. Asteroids and dwarf planets in this area have weirdly unexplained altered orbits, and Planet X may be the reason. Tales of this mysterious planet began over 100 years ago with a man called Percival Lowell. Lowell had a great love of space, and aside from having an impressive mustache, he was also super rich. Ooh, that lucky guy. He used his riches to build an observatory in Arizona. He then dedicated it to study the odd motions of Uranus and Neptune. Their gravitational pulls are slower than those of all the other planets in our solar system, almost as if there is a giant hidden object pulling them off course. In 1906, Lowell theorized that there could be another planet out beyond Neptune. It probably caused those strange cosmic happenings. The man called this potential space body Planet X. In 1930, Pluto was discovered by Clyde Tombaugh at Lowell's very own observatory. It finally looked like people had an explanation for the weird orbital patterns. Lowell's team was on cloud 9 after the discovery, but their celebrations were short-lived. Soon, they found out that Pluto is way too small to be having that much of an effect on the surrounding planets. And it was also too far away from them, so it was back to the drawing board. Planet X, if it exists, is 10 times the size of Earth and 4 times its radius. It would take at least 10,000 years for the planet to orbit the Sun, and it would sit over 200 times further out than our home planet. That's 600 astronomical units from the center of the solar system. FYI, an astronomical unit equals the distance between the Earth and the Sun. But while that sounds super far away, it's actually not. The distance between space bodies is usually measured in light years, and an astronomical unit is a much smaller unit of measurement. For context, the most distant thing detected from Earth is the galaxy GNZ11. Cute name, huh? It sits a staggering 32 billion light-years away. Even so, our telescopes can still spot it, and just 1 light-year is the same as 63,241 astronomical units. Woo! So, if our tech can detect a galaxy that's so far away, how have we not been able to uncover Planet X? Well, it's probably down to the fact that it might not even exist. The theory of Planet X was pretty much debunked back in 1989. It was discovered that the mysterious gravitational pulls of Neptune had been a red herring all along. Scientists had massively misjudged just how big Neptune actually was. Voyager 2 visited the planet and discovered its actual size. This new info explained the odd gravitational pulls, meaning they weren't being caused by the so-called Planet X. But that's not where our investigation ends, as the hypothetical 9th planet once again popped up around 10 years ago. While the evidence behind Lowell's theory was wrong, his belief in Planet X may not have been. In 2015, astronomers Michael Brown and Konstantin Batygin discovered that there were, in fact, unexplained gravitational forces at play past Neptune. There are satellites that orbit planets perpendicularly, which doesn't happen anywhere else in our solar system. There's also clusters of asteroids that move in very specific ways, so specific that it's basically impossible that it could be random. Even weirder, there are satellites that travel in completely opposite direction to the Sun, unlike most other things in the solar system. A planetoid called Sedna also appears to be being pulled towards something, along with 6 others, all going in the same direction. And Brown and Batygin aren't just any other stargazers. They're both well-respected scientists at the top of their game. Konstantin Batygin has been named in Forbes as one of 30 scientists who are changing the world. And Mike Brown was the man who rebranded Pluto as a dwarf planet. This means that when these guys say something, it's usually pretty legit, and you should probably listen. But the only way we can really prove Planet X exists is to actually find it, and this has turned out to be pretty difficult. To locate the planet, we'd need to use a method called transit photometry. This is basically where we monitor a whole bunch of stars for a long time and look out for any dips in the light they give off. These dips would likely be caused by a planet getting in the way, and ta-da! The existence of Planet X could be proved. But for this method to work, Earth, the new planet, and the Sun all have to be perfectly aligned. These circumstances are pretty rare, and if these conditions don't exist, the dip in light won't happen. Plus, this method would only really work with planets that are closer to the Sun than our Earth. That's Venus and Mercury. For anything past Earth, this technique is pretty much useless. Another technique we could use is to find the potential planet through a good old-fashioned telescope. But, as you can imagine, that's insanely tricky. The furthest object that we've found in our solar system is a planetoid appropriately named Far, Far Out. But that's only 140 AU away from the Sun. That's only like a quarter of the way to Planet X. We can only see an object because of its brightness. The Sun is very visible to us because it emits huge amounts of light. And we can see the Moon because it reflects the Sun's light. Technically, the Moon has no right to appear brighter than everything else in the night sky. It only seems brighter because we're closer to it. The farther away an object is, the less bright it appears to us. The major issue with seeing the theoretical Planet X is that all objects in our solar system get their light from the Sun. They reflect sunlight, and that's why we can see them. Given how far away from the Sun Planet X might be, it makes it nearly impossible to see. And because of its really dim light, to view it, we would require perfect weather conditions as well as an extremely strong telescope. But Brown and Badigeon have found the perfect one. The Subaru telescope is located at the top of a dormant volcano in Hawaii. It's huge and is capable of capturing even the weakest light from distant space objects. The issue that we need to figure out is where to point it. Without knowing where Planet X actually is, this basically turns things into a giant guessing game. There are also only around 3 nights every year when the conditions are clear enough to see the hypothetical Planet X. It's difficult, but not impossible. And still, most astronomers have called it a day and agreed that Planet X doesn't exist, stating that it's just a common myth. The most widespread explanation for the weird gravitational pulls is that there's a tiny black hole in our solar system. It's pulling the planets toward us. But don't worry, they say it's not big enough to actually munch on a planet. So Earth is all good, for now. The issue with the black hole theory is that, once again, it's almost impossible for us to track the thing down. While its mass could be as great as that of Planet X, the hole itself would be squished down to the size of an orange. Telescopes wouldn't be of any use. To find it, people would have to look for the gamma rays sent off by objects as they fall into the black hole. Another way we could find it is to release hundreds of tiny spacecraft. They would pass close enough to the hypothetical hole, and when they got pulled toward it, we could probably detect it. But don't count out Brown and Badigeon's theory. It's still being documented by NASA. And until we find unmistakable evidence to prove any theories, Planet X might still be out there. Dark, mysterious, cold space. Comets, asteroids, planets, stars, and something that's lurking over there, far beyond Pluto. Yup, this could be the 9th planet of our solar system, the one people have been wondering about for centuries. IRAS, which stands for the Infrared Astronomical Satellite, collected interesting data back in 1983. It could be proof that Planet 9 is hiding there. No one knows if it really exists, but this discovery helped to build a model to understand this potential planet better. And in 2016, scientists found out that some small space objects in the Kuiper Belt were orbiting a bit oddly. The Kuiper Belt is the outer area of our solar system. It's a ring in the shape of a donut, filled with leftovers from the times when our solar system was forming. You can find this donut beyond Neptune. The objects in that region of space have weird orbits, almost as if a big body with strong gravity is pushing them away. Knock knock, Planet 9 again. The theory says it might be 5 to 10 times the mass of our own planet and up to 20 times further away than Neptune. The astronomical unit equals the distance between our planet and the Sun. Pluto is approximately 40 astronomical units from the Sun, but Planet 9, if it exists, is 400 to 800 astronomical units away. It would take 10,000 to 20,000 Earth years for this mysterious planet to make a single circle around the Sun. This makes it harder for us to catch this space body. There's a theory Planet 9 may have formed between the orbits of Jupiter and Neptune, similar to the rest of the gas giants in our solar system. The gravitational force of one of the two huge planets probably kicked it out of its orbit. Oh no. Then Planet 9 could get ejected further away from the 8 planets we know about. It ended up as some sort of icy waste, quite small at the beginning. But as time went by, Planet 9 has cleared its orbit of frozen pieces of rock and dust and finally formed into a real planet. Another theory says that this could be a planet another star lost on its way while it was passing near our solar system. In any case, Planet 9 probably doesn't reflect that much sunlight since it's so far away. And astronomers aren't sure where exactly they should look for it. Space is dark, mysterious, endless, obviously. But if we do find Planet 9, it will be the first solid proof there are more planets in our solar system than we thought. Moving on to an interesting exoplanet, located only 90 light-years away from us. An exoplanet is generally a planet located outside our solar system. This one has an atmosphere with water clouds. 1 year there lasts 24 Earth days, and the planet travels around a red dwarf star, which is way dimmer and smaller than our Sun. That's why, even though the planet is 8 times closer to its star than we are to our Sun, the temperature there is similar to that on our planet. This exoplanet has a size similar to Neptune. It's also less dense, which means it's mostly made of gas, unlike Earth, which is made of rock. The average temperatures there is 140 degrees, which makes it one of the coolest small exoplanets we've ever discovered. And the cooler the exoplanet is, the bigger the chance we'll find clouds in its atmosphere. Researchers have discovered more than 4,000 exoplanets, but all of them have been found within the Milky Way, at least until now. For the first time, astronomers may have spotted a planet outside our galaxy. They called it M51 ULS-1. The planet is located in the Whirlpool Galaxy, a distant spiral galaxy 28 million light-years away from us. There was once a huge but pretty young star that got stuck in a gravitational dance with something that could be a dense neutron star, the collapsed core of a giant star, or a black hole. The star's dance partner had incredibly strong gravity. It was feeding on the star, greedily ripping away its plasma. Then something unusual happened. An unknown, maybe even Saturn-sized object passed by and blocked this confrontation from our solar system. Now no one can see what is going on. But this could potentially be the farthest planet we've ever discovered. There's a newly discovered planet outside our solar system. As large as Jupiter, it orbits 2 stars. And, as we can observe it from our planet, it crosses in front of them both. The full circle around these 2 stars, which means 1 year, takes approximately 200 Earth days. On the day of the discovery of the previous planet, scientists also found it had an unusual companion. It's an extra-hot Jupiter with an ultra-tight orbit around its star. The year there lasts only 1.9 Earth days. This planet has a weirdly shaped orbit. Also, it travels in the opposite direction from the rotation of its star. If you could travel 57 light-years away from our planet, you'd see something pink lurking in the darkness. As you get closer, it becomes bigger and more fascinating. Yup, it's a magenta-colored planet. A few billion miles away from its sun, this guy is one of the youngest planets scientists have discovered. It's only 100 to 200 million years old. It's made of pink gas, similar to our Jupiter. So, if you could fly closer to its surface, this gas would envelop you like a thick fog. You're coming closer and going deeper, and the gas is becoming darker, getting a reddish shade. And look at the planet's core. It's super hot. Because of its high temperature of 460 degrees Fahrenheit, this planet is like an oven. The heat is the reason the planet glows so brightly. You'll also notice the sky is hazy pink, with clouds made of droplets of frozen water, similar to ours. There's another exoplanet half as massive as Earth, which is one of the smallest planets we've ever found outside our solar system. It has a diameter of 5,600 miles. For comparison, Earth's diameter is 7,900 miles. The planet in question is mostly made of iron, similar to Mercury. Mercury has a massive iron core and a very thin crust, which makes it an oddball in our solar system. At its early stages, it collided with some space body at least once. That collision pulled its outer layers away, which is why only the firm iron core remained. Maybe this exoplanet participated in a huge space crash too. That's what probably took away the planet's mantle and left mostly its iron core. Or maybe this is just a remnant of a gaseous planet that used to be the size of Neptune. The atmosphere of the planet could be blown away by, let's say, a huge amount of radiation coming from the star. This planet is only 31 light-years away from us, and the day there is less than 8 Earth hours long. The planet is only a little bit bigger than Mars. People aren't likely to ever settle in that place because of its extreme temperatures that go up to 2,700 degrees Fahrenheit. There might even be molten lava on the side of the planet that faces its star. Such temperatures are high enough to evaporate any atmosphere, so this planet might have had one in the past. Generally, gas giants like Jupiter can't support life because they have extreme weather conditions, temperature, and pressure, and there are no building blocks that might create life. But smaller terrestrial planets, such as, Earth, have more key ingredients like oxygen and liquid water. Plus, they have more temperate weather and other conditions. And still, not all of such planets support life, of course. It's not easy to find a planet with similar conditions as the ones we have on Earth, or at least the conditions that would allow life to develop there. But meet Kepler 22b, one of our most promising findings. It's 600 light-years away from us, twice bigger than our planet, and with temperatures of about 72 degrees Fahrenheit. This is a so-called super-Earth. It's a category of planets unlike any we have in the solar system. They're more massive than Earth, but still lighter than ice giants such as Uranus or Neptune. Super-Earths can consist of rock, gas, or a mixture of these two. Kepler 22b is within the habitable zone of its parent star, which is less bright than our Sun. The planet probably has a rocky core. It may have an ocean, but it doesn't host any life. At least, we don't know about it yet.
How about a mysterious object that used to orbit between Mars and Jupiter? At one point in the early days of the solar system, it was destroyed by some catastrophic event. This space body is called Feton, and this planet is totally hypothetical. But some people believe that the debris the planet left behind could have formed the asteroid belt. If you like this kind of content, please give it a non-hypothetical like and subscribe. Your support is very important to us. Thank you. Now, at the start of the 19th century, people hadn't discovered the asteroid belt yet. But in 1801, one astronomer spotted the largest asteroid in our solar system, Ceres. At that time, it was believed that a planet was orbiting between Mars and Jupiter, and Ceres seemed to be a suitable candidate. But the next year, another astronomer discovered one more space object with a similar orbit. It was an asteroid that was later named Pallas. These discoveries made scientists conclude that these two objects could have been fragments of the very planet that had once been dwelling between Mars and Jupiter. The following discovery of two more asteroids, Juno and Vesta, seemed to confirm this idea. Only in the 20th century did the hypothetical planet get its name, Feton. It was actually a name taken from Greek mythology, meaning shining one. The hero with this name was the son of the sun deity, Helios, who rode his solar chariot across the sky every day, giving humans the heat and light necessary for survival. One day, Helios allowed Feton to drive his chariot. But the sun didn't manage to control the horses. Everything went wrong, and Earth was about to burn down. That's why the main deity, Zeus, had to stop Feton with a thunderbolt. The idea of the asteroid belt being the sad result of the planet's destruction was called the disruption theory. And of course, there were several ideas explaining the planet's tragic fate. The most obvious one is that Feton was hit by a large space object. It could be another hypothetical body called Nemesis. Some people believe that it's our sun's companion star. According to this theory, the sun has a small companion star that has an extremely elliptical orbit. This orbit periodically brings it close to the Oort cloud, a large sphere of icy objects surrounding the sun. This, in turn, causes a lot of mess. It might be the reason why this hypothetical companion star was also nicknamed the Death Star. It might be a red or brown dwarf. But whatever it is at the furthest point of its orbit, it's believed to be about 1.5 light-years away. The search for this star has been in progress for decades, but no one has succeeded in locating this elusive and potentially non-existent space object. Anyway, back to Feton. Another theory claims that the planet could have suffered some internal cataclysm which tore it apart. But these days, the disruption theory has fallen out of favor. It was replaced by the accretion theory. According to it, the asteroid belt formed in the process of gradual buildup of particles initially floating in a gaseous environment. With time, they came together to create larger masses. Gravity pulled on these particles, encouraging them to stay together and form planetesimals, tiny planet-like bodies that later form real planets. Planetesimals kept colliding with one another, eventually developing into protoplanets. Such protoplanets grow until they form planetary bodies. As the mass of objects increases, the gravitational forces acting between particles become stronger too, continuing to build gas, dust, and ice within the nebular disk. It all has a snowball effect where the increase in mass results in more particles getting involved in the process. Eventually, there's no building material left, and large space objects float in the darkness of space. Now, many experts think that the asteroid belt is the remains of the protoplanetary disk which had once been orbiting the Sun before the planets formed. Unfortunately, it never had a chance to coalesce into a planet because Jupiter's gravitational effect prevented it from happening. In any case, even though Feton's was a good story, it's not popular anymore.
In 2021, astronomers announced that they had found between 70 and 170 free-floating planets. Such planets are also called rogue because they don't orbit around any star. And the majority of these huge unattached planets, each approximately as large as Jupiter, dwells in one particular region of the Milky Way galaxy. It's known as the Upper Scorpius OB Stellar Association. Wow, doesn't it sound like the name of some homeowners association? Anyway, this conclusion was made by a team of astronomers that used telescope observations from all over the world and in space. They also looked through 80,000 wide-field images taken over a couple of decades. Scientists have estimated there might be billions or even trillions of rogue planets wandering around our galaxy. If their estimations are true, it might mean that the Milky Way contains more free-floating planets than stars. Ooh. This region of the sky is around 420 light-years away from Earth. A lot of amateur astronomers are familiar with it since lots of cool stuff is located there. The most famous targets for astrophotographers include dark nebula, like Barnard 68, Coal Sack, or Pipe Nebula, as well as the colorful region around Rho Ophiuchi. But let's get back to mysterious rogue planets. They wander the galaxy alone, totally untethered. Without stars, they don't have days or nights, only eternal darkness. Of the thousands of planets scientists have detected outside of our solar system, only a dozen or so are starless and cruising on their own. Recently, astronomers have announced one more finding, the tiniest known rogue planet. The mass of this space traveler is somewhere between the masses of Earth and Mars. The term itself, a rogue planet, suggests that such celestial bodies might desert their stars on purpose. They wander off on their own, carving a new path through the Milky Way. But the reality is much more tragic. Rogue planets are usually kicked out of their star systems, doomed to a solitary existence of circling the center of the galaxy on their own. How sad. You see, things get messy when planetary systems, including ours, form. While planets appear from the cosmic dust surrounding a newborn star, they jostle one another around. This gravitational game of pool can easily shove some planets toward the edges of a star system, or eject one or two of them altogether. Then there are also nearby stars that can shove planets around too. Most stars are not born on their own. Clusters of dozens to thousands of stars often appear in space. No wonder that in such a crowded environment, a star with its own set of planets might whisk away a planet or two from another star. After stealing a planet, it can keep it for itself or cast it out into space. At the same time, some free-floating planets might form in a different way, with no parent star to help them. They appear from collapsed clouds of gas and dust, just like stars do. But sadly, they don't manage to put on enough weight to start nuclear reactions, the ones that make stars emit light. These objects are also known as failed stars. Hey, who said they failed? And they resemble planets. Rogue planets are very hard to detect. When astronomers want to find an exoplanet, they look for something blocking the light of its parent star. That's usually the planet passing between the star and the observer. But researchers can't use the same technique with free-floating planets because, in this case, there's no parent star. The only way to locate them is to rely on gravity. Now, imagine a line of sight between a telescope on Earth and a distant star. When an object crosses that line, its presence is likely to bend and magnify the star's light. This, in turn, makes the star appear brighter than usual. As for the duration of this brightening, it depends on the nature of this moving object. If the brightening lasts a few days, it's a star. If the duration is about a day or so, it's a Jupiter-mass object. And if it's just a couple of hours, this object is something that equals the mass of our planet. But the trickiest part is to figure out whether this object is indeed a rogue planet. It's true that stars whose light such celestial bodies bend can't be their parent stars. They're too far away. But there still might be a parent star, invisible because of the glare of the luminous star. And astronomers have to wait up to a decade for the luminous star to move a bit to check for a potential parent star. If there's still no parent star in sight, then it's proven. The planet is traveling solo. One thing is clear. Without parent stars to warm them, rogue planets are frozen worlds. Even if ice doesn't go all the way down to their cores, it certainly covers such planets with hard, icy shells. On the bright side, maybe free-floating planets aren't as lonely as we think. They might have moons of their own. They probably take them along when they get pushed out of their cosmic homes. Even more exciting, these exomoons might have liquid water. At least that's what a 2021 study published in the International Journal for Astrobiology claims. Actually, I don't get that magazine, but it sounds fancy. But could a free-roaming world find a new home near a different star? Some experts think it's unlikely. The universe is an incredibly spacious place, and even a large star is hardly able to slow down enough to lasso a fast-moving planet. For example, in 2017, an interstellar guest, an asteroid the size of a skyscraper, appeared in our solar system. It barreled through the solar system and just kept going without stopping or slowing down. But what if it was a rogue planet? Would it stay with us? Astronomers say it's unlikely. If it happened, they would be thrilled, such a research opportunity. But the rest of us would likely be terrified by the implications of having such a neighbor. At the same time, maybe it wouldn't be such a big problem, considering how big and very empty our solar system is. But even without a rogue planet invading our solar system, the orbits of our planets are going to change one day. In 5 billion years or so, the sun will start to dim. It'll begin to lose its mass until its gravity is too weak to hold on to the outermost planets of the solar system. Neptune, Uranus, and probably Pluto might turn into rogue planets. They will slowly drift away, unbothered by the cold and mostly unchanged due to their already frozen environments. And yeah, I know the scientists demoted Pluto as a planet years ago, but it's still a planet to me, so sue me. And what about Earth? Oh, our planet will have a different fate, much more tragic. As stars lose mass nearing the end of their lives, they eject gas and dust in all directions. And since our planet is in the way, it'll most likely get enveloped in this scorching stream and vaporize. But calm down, it won't happen for a few more billion years. And who knows where humanity will be at that time. As for now, astronomers hunt rogue planets with enthusiasm. For example, NASA's Nancy Grace Roman Space Telescope is going to conduct a survey to discover more free-floating exoplanets using its powerful techniques of a wide-field telescope. The stars in our Milky Way galaxy move all the time, and chance adjustments of the telescope can help researchers spot rogue planets. But there's one drawback. We won't know the distance to such a planet even if we find one. There's one more mission concept, cleverly called Cleopatra. It might be able to exploit parallax effects to calculate the distances to rogue planets. Parallax is a shift in the position of a foreground object when seen by observers in slightly different locations. To maximize this effect, Cleopatra might hitch a ride on a Mars-bound mission. It's supposed to place it in orbit around the Sun. That's a sufficient distance from Earth, which can help the mission effectively measure the parallax signal and fill in the missing information for astronomers. There are a lot of space objects all around the universe, from stars to planets to satellites, comets, and asteroids. But our closest celestial body is the Moon, which has been subject to much research, theories, and even myths. As our only natural and permanent satellite, the Moon is in the top 10 list of biggest satellites in our solar system. It's located in an outer spiral arm of the Milky Way galaxy. Other planets in our solar system, like Mars or Jupiter, have many other moons. Saturn is the planet that tops this list, with an astonishing 82 moons, of which 53 have names. Shall I go through that list of names? No? Okay, we'll move on. Our Moon, with its mean radius of 1,079 miles, isn't the biggest moon in the solar system, but is the largest compared to the size of the planet it orbits. The difference between a satellite, like the Moon, and a planet isn't their size, although that might be your first thought. The largest moons in our solar system are really huge. Some of them are even bigger than planets. Jupiter actually has a bunch of these types of satellites, like the icy Ganymede. It's the largest moon in our solar system, larger than Mercury and Pluto. It may even have an underground saltwater ocean that can surpass all the water on Earth's surface. Our moon's diameter is a bit larger than a quarter of that of the Earth. When it comes to mass, though, it's 80 times less than our Earth's. To paint you a better picture, if you think about our planet as being a big hollow balloon, you would need about 50 moons to fill it. But let's look at our moon's size from a bit of a different perspective. How does it compare to the United States? Well, the US measures 2,800 miles wide horizontally, which means the moon is smaller in diameter. It's difficult for us to see it any other way, but what if our satellite was twice as big? Well, first, we would see way more of those solar eclipses. In present conditions, they can happen 2 to 5 times a year, and 5 times is more of an exception. The last time there were 5 solar eclipses in a year was back in 1935. You'll have to wait until 2206 to see the next event like this. I might be around for that. If the Sun and the Moon look about the same size from down here on Earth, but I guess it won't be a surprise if I tell you the star we're orbiting around is enormous. So if the Sun was hollow, how many moons do you think you'd need to fill it up? Wait, no need to Google. You would need 64.3 million Earth moons, or about 1.3 million Earths. Yep, it's that huge. And while we're on the subject of our Sun, it has a diameter of 864,000 miles. Its mass? Well, it's no less than 330,000 times bigger than that of the Earth. What is a star, though? I'm not a scientist here, so I'll try to keep it simple. It's a ball of bright, flaming hot matter held together by gravity. The reason why they give off both heat and light is that, well, they are very hot. Experts call the smallest stars red dwarfs because of their size and color. They're also the most frequent types of stars in our galaxy, with some of them being so tiny and dim they are invisible to people on Earth. It's the case of our nearest neighbor star, Proxima Centauri. Our Sun is considered a medium star since it has an average mass, brightness, and life expectancy. There are also giant stars out there. They are rarer but easier to see. That's why you can safely assume that roughly every star you see after the Sun is set is much larger than the Sun. But enough about it. Let's bring it back to the star of today's show, the Moon, our only natural satellite. But is it? That may or may not be the full truth, actually. Back in 1997, a group of scientists stumbled upon an asteroid about 3 miles wide, looking like it was caught in Earth's gravitational grip. It looked like a satellite of our planet. They called it Krunia. It takes this guy about 770 years to make a trip around the Earth. It also seems that it will remain in a suspended state around our planet for at least another 5,000 years. The moon is also kind of steering away from us. With each year, it essentially holds up some of our planet's rotational energy and uses it to launch itself about 1.5 inches higher in its own orbit. If the data we have available today is correct, back when it was born, our moon was about 14,000 miles away from us. The distance now is 239,000 miles on average. So, what will happen when it moves away completely? Well, no more songs like Moon River, Fly Me to the Moon, How High the Moon, that's for sure. Then there will simply be no tides in our planet's oceans, and our nights would become darker. The seasons would look a lot different, and so will the lengths of our days. Based on current calculations in the science world, this will take about 50 billion years or so. So there's no need to rush out stocking up on flashlights just yet, unless you just like to hoard stuff. There's also another catch here. Our sun gets about 10% brighter every billion years. I'll spare you the calculations, but to sum up, it's more likely that long before the Earth will be left without its moon, the sun will have already swallowed them both. Gee, I don't find that any more comforting. But hey, what makes a planet, well, a planet, and why isn't our moon considered one? I mean, it's bigger than some other objects in our solar system, which are technically planets. For starters, a planet is a celestial body that does 3 things. It orbits around a star, not something else. It is massive enough to become roundly shaped because of its own gravity. And lastly, it has the power to snatch up any dust or fragments in its orbit as it continues to move around the sun. So, we've established that the moon doesn't orbit the sun, but it doesn't really orbit the Earth either. Both of them orbit a certain point stationed between them called the barycenter. It's about 1,000 miles below the surface of Earth, sure, but still some 3,000 miles from the center of our planet. Since this barycenter lies beneath the surface of Earth, we do not consider the moon a planet. To be able to do so, the moon would have to be either about 1/3 larger or 1/3 further away, so that the barycenter would be independent of Earth's surface. The moon does have some other planet-like characteristics, though, which makes it very special in our solar system. Firstly, it has a crust, a mantle, and a core. It also has quite an active geology, with events like our own earthquakes. You guessed it right, they're called moonquakes up there. Hey, do they have moon pies up there too? Nah, come on. Let's continue our space exploration a bit more. Wait, what? You can't hear me? Of course you can't, because space is utterly silent. Since there's no atmosphere in space, sound has no medium or way to travel for you to hear it. You will want to steer clear of Venus if you do wish to continue your outer space travels. It's the hottest planet in our solar system. It has an average surface temperature of around 840 degrees Fahrenheit. Hot! You'd think that's because it's closest to the Sun, but it's not the case. You would also think that the closest planet, Mercury, would then be the hottest. Well, since this one has no atmosphere that would help regulate the temperature, it tends to have bigger fluctuations. Your calendar would also be very messed up on Venus, since one day on its surface is about as long as a year on Earth. That's because Venus is rotating slowly around its axis, taking 243 Earth days to complete its own day. If you were to pit stop on Mars, be on the lookout for those blue sunsets. According to NASA specialists, there is some fine dust that makes the blue near the sun's part of the sky much more visible on Mars. Any diamond fans out there? Pack your bags, because there's a planet out there made of diamonds, and it's twice the size of Earth. They believe it's mostly covered in graphite and diamond. A spacesuit costs about $12 million, but a visit there would cover the expenses altogether, don't you think? And if you're not a fan of space explorations and prefer the comfort of our planet, here's some good news for you. We have more trees right here on Earth than there are stars in our galaxy, the Milky Way. We know there are about 3 trillion trees here on planet Earth, and between 100 and 400 billion stars in our galaxy.
One day, NASA will build a spaceship that can take us anywhere in the universe. Probably. And when this happens, we'll be able to find a new, beautiful home. Scientists even know what exactly they're looking for. We want a planet about twice the size of Earth with an average temperature of 77 degrees Fahrenheit, with a pretty dense atmosphere. Bigger planet means more room for water and potential homes. And a dense atmosphere means more protection from nasty space stuff, as well as more lush plants and cool animals. Thanks to the James Webb Space Telescope, we can now study exoplanets better from a distance. Of course, sending astronauts there would be much better, but oh well. Discovering new planets isn't easy though. It's like trying to find a tiny firefly in a pitch-black forest. Scientists had to come up with a clever method to find very distant planets. It's called the transit method. Here's how it works. Scientists capture a series of snapshots of a distant star at different points in time. Then, they scrutinize these images. They try to find any mysterious dark spots passing in front of the star. If they find one, it could very well be a planet. These snapshots hold the keys to uncovering vital information about these distant worlds. Not only do they tell us that there's a planet there, but also reveal its size, radius, and how close it is to its parent star. And most excitingly, they hint at whether it could ever become a new home for us. And now their research is finally bearing fruit. Recently, we've stumbled upon a tiny world nestled in the Cygnus constellation. It's called Kepler 22b. At first glance, it might not seem like a big deal, but this discovery has some pretty huge implications. This planet is located right in the Goldilocks zone. The Goldilocks zone, also known as the habitable zone, is a sweet area around a star where the conditions are just right for a planet to have liquid water on its surface. It's not too hot, so it doesn't evaporate, and it's not too cold, so it doesn't freeze. Hence the name from the famous story of Goldilocks and the Three Bears. So there might be water on Kepler 22b, and where there's water, there's a chance for life. And it's not just about life. Having a planet covered in oceans can be a game changer for climate stability, all because vast water bodies act like nature's thermostats. When the sun beats down on the hot parts, the water soaks up some of that heat and spreads it around like a blanket. The scorching regions cool down and the icy ones warm up and thaw out. Back in the bad old days of our Earth, the moon played a crucial role in helping water puddles spread across our planet. This is what helped our world transform from a fiery nightmare into the vibrant, life-packed orb we call home. Kepler 22b has about the same year length as our Earth. And if we're right about the whole ocean thing, scientists think its average temperature could be around a cozy 12 degrees Fahrenheit. But if this world also sports an Earth-like atmosphere, temperatures might soar up to a toasty 72 degrees. This world isn't too far away from us, only 635 light-years, which is about 3 quadrillion miles. Yeah, that's pretty close in space terms. Its sun is a yellow dwarf star, just like our sun, although there's a subtle difference. It's about 20% dimmer, so you won't see this star in the night sky even if you squint your eyes really hard. This star also happens to be quite chilly. Its temperatures are hovering around a frigid 10,000 degrees Fahrenheit, making it the Arctic of the starry skies. Luckily, Kepler 22b snuggles up to its star a bit more closely than we do to the sun. If it was in our solar system, it would find its place somewhere in between our familiar Earth and Venus. So the brightness and the temperature on this planet would be almost the same as on Earth. There are a couple of catches though. For example, this world might be quite a gymnast. It could be twirling around its star in a totally different way than Earth does. It might be tilted, like Uranus. If that's the case, the temperatures of the planet could be quite weird. You'll experience bone-chilling winters, followed by scorching hot summers. So let's hope this theory isn't true. If Kepler 22b has a normal tilt, its climate would be pretty similar to what we enjoy here on Earth. The next problem is gravity. Kepler 22b is about 2.4 Earth's size, which means the gravity there would be stronger. You'd feel noticeably heavier on this planet. It would be just like doing your everyday activities on Earth, but everything would require more effort due to the stronger gravitational pull. Simple things like climbing stairs or even just breathing would require much more energy. So it's time to build some muscles. People would have to adapt to the new conditions by having denser bones and more robust cardiovascular systems just to move around comfortably. Unfortunately, that means doing sports would be much harder too. But hey, at least people might need to consume more calories to sustain their activities, so even though you'd have to exercise more, you'll also be able to eat more delicious food. Buildings on Kepler 22b would likely be square and robust to withstand the stronger gravity, which would kinda be problematic because taller structures are super challenging and expensive to build. But the most important question is, what kind of planet is that at all? Yeah, it's the big question mark. Scientists aren't even sure that Kepler 22b is Earth-like. It could be a gas giant, or even a water world. A water world is a planet with a vast ocean covering its surface, and it's not just some knee-level deep water. It'll be insanely huge, thousands of miles deep and more, with no visible surface or any plants around for a long time. In that case, we could dream of building underwater cities. We could filter the water for sustenance and perhaps evolve into amphibious beings. Would that be a step backward or a leap forward in our evolution? Some scientists also lean towards the idea that Kepler 22b might be a mini Neptune. This is a legit planetary category, by the way, but that theory is still unproven. But let's say, for our sake, it's a rocky planet. Even then, we're in the dark about its atmosphere. Does it even have one? What if it's like Venus, toxic enough to make your ex look like a bouquet of roses? In that case, we'd have to dig deep into the planet's depths for survival, figure out a heat source, and hope for the best. While there's a lot we don't know, let's keep our fingers crossed and assume the planet is Earth-like. In that case, what would Kepler 22 look like? Well, because of stronger gravity, the planet's landscape might be full of rugged mountains, deep valleys, and powerful rivers. If there's life on this planet, it's probably quite small. Unusual plant and animal life should have adapted to the higher gravity. Trees might be shorter and sturdier. They'd struggle to break free from the soil. Animals might be pretty small too. They would also have strong, muscular legs for support. Perhaps these creatures would have numerous legs, making movement possible. They'd need to be small in stature, but gargantuan in strength. Muscular giant spiders sound not so bad, right? As for our beloved pets, they'd have to become little muscle-bound spheres just to survive. Also, the landscapes would feel very spacious because of the planet's sizes. A 3-day flight in a plane sounds like quite the adventure. There are many possibilities with Kepler 22b. So far, we don't have a clear answer. But let's hope that scientists will find it before we load the first people into shuttles and send them to conquer the planet. That would be awkward if it turns out to be a gas planet or something like that.
So scientists have this idea that some exoplanets, which are worlds outside our solar system, might be water worlds. They orbit their distant stars, covered by global oceans. Even better, some experts claim that our Earth was once the same, a vast expanse of the ocean, and just a bit, if any, visible dry land. At the moment, water makes up 71% of Earth's surface. Our planet experiences continuous movement of water. First, water evaporates, rising from the ocean surface to the atmosphere. Then rains fill lakes, rivers, and underwater reservoirs. Eventually, all this water ends up in the ocean again. Water also plays an extremely important role in the processes happening below the ground. For instance, water content in magma determines how explosive a volcano can be. Anyway, one of the most burning questions about Earth's water is, where did it all come from? It's very unlikely that our planet was simply born this way. The thing is, water has a way lower condensation temperature than some other substances, like silicates or iron. These materials compose the terrestrial planets in the solar system. In the early history of our planetary system, the region where Earth formed was too hot for the oceans to condense at the same time as our planet appeared. So, there's this idea that water appeared on Earth when melted meteorites hit the surface of our planets. Well, scientists disagree. Researchers analyzed some melted meteorites that had been hanging around in space since the formation of the solar system about 4.5 billion years ago. They discovered that those space rocks had extremely low water content. Even more surprising, they were among the driest extraterrestrial materials ever found and examined. In other words, once they melted, there was essentially no water left. These results were very important, since they helped scientists rule out melted meteorites as the primary source of water on Earth. Plus, we can say that this revelation was kind of eye-opening. Imagine the unlikely conditions that aligned to make our planet habitable. Getting water and developing surface oceans on a planet so small and so close to the Sun is a great challenge. If Earth had formed just a tiny bit closer to the Sun, our planet would have been much hotter, and all the water would have most likely evaporated. If it had been farther away from our star, Earth would have turned out to be much colder, and the water would have probably frozen into ice. The team of scientists managed to analyze 7 melted meteorites that had crashed into Earth. Those must have splintered from at least 5 space objects known as planetesimals that later collided to form the planets in our solar system. These planetesimals took part in something known as melting. They got heated up as a result of the decay of radioactive elements in the early solar system. This caused them to separate into layers with a core, mantle, and crust. Plus, the heating and melting of planetesimals apparently led to near total water loss, regardless of how much water they started with. As for meteorites, some of the samples arrive from the inner solar system where our planet is located. The conditions here are relatively warm and dry, so it's no wonder the meteorite samples didn't contain much water. But a few samples were from the colder outer reaches of the solar system. That's from where the water is believed to have come to our planet. But if this water hadn't been delivered by meteorites, what kinds of objects could have carried it all the way across our planetary system? There's one more theory, though, that hydrogen inside our planet played an important role in the formation of the oceans. At the same time, these two ideas are not mutually exclusive. Water could have been delivered to Earth by impacts from some space bodies, like asteroids from the outer edges of the asteroid belt, spanning between the orbits of Mars and Jupiter. And some amount could also appear inside our planet. There's also a theory that claims that Earth gradually grew by accumulating icy planetesimals about 4.5 billion years ago. At that time, it was still only 60 to 90% of its current size. According to this theory, Earth managed to retain a certain amount of water in some form throughout the process of accumulating its mass, and as a result of large impact events. It sounds quite plausible. The examination of the chemical composition of lunar samples brought to Earth by the Apollo 15 and 17 missions indicated that water had already been present on our planet before the Moon was formed. So far, all these ideas remain just theories. At the moment, we don't know for sure how water appeared on Earth. What we do know is that there are many other space bodies that have water in this or that state on their surface, or under it. Let's start with our dear Moon. On Earth's natural satellite, water can be found all over the surface, but it's probably not the water you imagine. You won't find pools of liquid water there. On the Moon, it's mostly ice. Some places have more water than others. For example, the poles of the Moon are regions that never get any sunlight. That's why they're extremely cold, and there's a lot of ice there. Plus, the ice in these areas is often mixed with the lunar soil and hidden deep below the surface. Then there's Jupiter's moon Europa. Astronomers consider this world to be one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, the temperature, pressure, and chemistry are far different on Europa. Scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water reservoirs on Europa are or how long they need to refreeze. Enceladus is the sixth largest moon of Saturn. It's not really large, only 314 miles across. This makes the space body small enough to fit inside Arizona. Wait, we should try that. Never mind. When the Cassini space probe first arrived at Saturn, astronomers thought that Enceladus was going to be a frozen ball of ice. But then they saw plumes of icy particles and water vapor erupting from geysers on the moon's surface. It became clear that there was a massive ocean between the moon's rocky core and its icy shell. If you've been imagining Mars as an extremely dry place, you need to listen to this. Scientists think there could have been a lot of water on Mars in the past. What makes them think so? They found lots of ancient river valley networks and lake beds on the surface of the red planet. Plus, on Mars, there are minerals and rocks that can only form in liquid water. Mars might even have experienced terrible floods 3.5 billion years ago. These days, there's still some water on the red planet. It's true that Mars's atmosphere is too thin for this water to stay in its liquid form on the surface of the planet. But under the surface, it's a different matter. You can find water in Mars's polar regions, but the only place where this water is visible is at the North Polar Ice Cap. Sometimes salty water flows down crater walls and hillsides, and there are tiny quantities of water in the planet's atmosphere, but it only exists as vapor. Since we know for sure there is liquid water on Mars, could we possibly use this water during the human-operated mission to the red planet? If we manage to do it, spaceships coming from Earth wouldn't have to bring their own water. It would make the cargo way lighter, which, in turn, would decrease the cost of the mission. We would just need to take enough water to get to the red planet and bring along the equipment needed for filtering Martian water to make it drinkable. Well, it sounds simple enough.